When we learn geometry, we hear the term plane geometry, but we never really consider how things would change if we weren't working on a plane. Let's take a look. Let's zoom out and see what happens on the Earth's surface if we are doing some large-scale geometry. For example, the longitude lines on our planet are all north to south, right? That means they're parallel, right? Let's take a look. Let's draw some longitude lines on our planet Earth here. If a couple of people start at the equator and start heading due north, each on a different longitude line, things are looking pretty parallel until they get further and further north. Somehow, they're meeting at the same point, the North Pole. How? I thought parallel lines didn't intersect. Another thing we know is that the sum of the angles of any triangle is 180 degrees. That works on a plane, like this screen, or a piece of paper, or even on a small area of the surface of the Earth. But let's zoom out again and take a look. If we're looking at a small triangle, it looks similar to our plane geometry. But when we start looking at bigger and bigger triangles, like this one that's created by these longitude lines and the equator, the angles clearly add up to more than 180 degrees. This angle appears to be 90 degrees, and we know that the equator and the longitude lines are perpendicular, so that's true. Well, if we add the sum of those two angles, we're already at 180 degrees. What happens when we add this top angle? We're well above that sum. Who knew? I wonder how much of this a sailor needs to know to actually find their way on a trip around the world. Looks to me like there's a whole new geometric world out there to explore.